Well, thanks everyone for coming. I'm excited to do this. It's my first presentation in years because of the pandemic, so it's fun to do. And I think in honor of that, we had one of our engineers set up a live demo, and I told him to stop updating the demo 2 days ago, but he just continuously is pushing code even now. So it's going to be an exciting live demo that I get to do for all of you. I guess I'd love to do a quick poll. I've been kind of walking around the conference and asking people, but I'm just curious, how many people, I don't know, trained a model in the last year in 2022? I'm just want to get a feel for that. Awesome. And how many people have you actually used Ray themselves, or any skill? Cool. And has anyone used weights and biases? Awesome. OK, cool. Thank you. So it's about half of you for all of that. So I'm going to try to make this accessible for everyone, but we'll get a little deeper in the technical content. All right, so I guess for those of you who haven't trained the model in the last year, we have this sort of obligatory slide that ML is transforming every industry. And I just, I know that everyone puts this in their slides, but I just really, really enjoy this. I've been, basically making ML tools for the last 20 years, and it's so fun to see companies like, John Deere basically, making autonomous tractors with machine learning, and seeing basically 3 years ago we had no pharma customers. Now we have almost every pharma company at least using us in some level, and actually designing new drugs that really get used. And so it's just kind of an incredible moment for machine learning. A little bit about me and my company. So my two co-founders and I started a company called Figure 8, which maybe some of you used back in the day that collected training data for machine learning. And we've been doing weights and biases for about 4 years. We have, we've actually grown. I would say, we met Anyscale, Ray, about 4 years ago, right when we started, and we did our first integration with Ray when I think we were 3 people and they were 4 people, and so it's kind of fun to be at this big conference. The thing that we were looking at, when we started the company, I think this was from our initial investor slides. We have one of our initial investors right here in the front row, so can verify. The thing that we were honestly seeing is basically that, Andre Karpathy talked about Software 2.0, actually at a Figure 8 conference that we did. And it really kind of opened my eyes. So wow, there's a really different workflow for people that are doing machine learning. And I think that's really true. I think it kind of looks like software development, but the workflow, has some key differences. And even steps that you would think would be the same, don't get the equivalent in software, right? Production monitoring for software is totally different from production monitoring for model training. And you know that because people, New Relic has had a ML production monitoring thing out there for quite a long time. Nobody uses it, right? Nobody even considers it, right? Whereas people, build their own ad hoc production monitoring systems. And experiment tracking. I was just joking in the front row. Another friend of mine, Dwight, actually was doing experiment tracking right when I started the company, and was showing me his notes and literally showing me how he was. He had a 100-page Google Doc of all of his notes on the models that he was making. So clearly, he's not checking his models into GitHub or GitLab. I don't know what he's doing. Sorry, I'm in S3 or what, maybe on his laptop. But and so you sort of see at these stages, right? You see that the tooling is not getting used. And now, of course, it's 4 years later, we see all these ML tools companies, all these options. But I would still argue and maybe ask yourself, for these buckets, you probably have these buckets that you're using, but you're probably still doing ad hoc things if you're like most of the people that we talk to. And so the ultimate ambition of weights and biases is to basically build solutions for each of these boxes. And we really want to build them for the ML practitioner, for the person building models, which means that if you want to use a different data versioning system, we want to make that really comfortable for you. And if you want to use a different production monitoring system, that's OK. We want to work with everything out there. But we really want to offer best-in-class stuff for these real pain points that ML practitioners run into. And I have one more obligatory brag slide, since you invited a startup CEO to this conference. But I really do feel super proud of this business, right? We've had incredible growth in active users because people really like the product, right? So we survey everyone that uses it. We ask them, would you recommend the product? And 77% of the people give us a 9 or a 10. And over 70% of the people say they'd be very disappointed if they can no longer use weights and biases. So I think that's the most important question, and it's the most important thing. So I'd say if you haven't used us, please try us, and hopefully you'll feel that way about us. So Another kind of key thing that we knew from the very beginning of the company was that we love building useful software for other developers, right? Me and my co-founders have always loved that throughout our career, and we hate building infrastructure. It's scary to build infrastructure. We're not great at building infrastructure. It's like not like our core competency. And so this is why I think it's really perfect to partner with a company like Anyscale and a product like Ray, because we knew, we all train models, right? We all have these problems of trying to get, literally just getting something running on a GPU is painful. It was painful 4 years ago. It's still painful. I don't know why, right? Everybody kind of runs into it. Everybody knows, everyone's learned a little bit about CUDA and CUDANet and all that, and probably run into more linker errors than you encountered in the decade before. But we're so happy to have products like Ray that abstract that away, right? And so the stuff that we do, which is kind of more interface driven, I think integrates super, super well with Ray's vision. That's one of the reasons that we see so many people using weights and biases and Ray together. And so ultimately, our system has a lot here, and I won't go into all of it. But there's a lot behind the scenes that you can use, and I'll show you things like reports we feel really proud of, where we've learned over the years of doing this that not just just kind of keeping track of people's data sets and keeping track of people's models and experiments, isn't enough. You need to let people collaborate between each other. You need to integrate with all the tooling that ML teams actually use. And so, ultimately, we work with lots and lots of customers. We're kind of known for, working with developers and having a bottoms-up strategy. But many enterprises have, partnered with us from OpenAI and Google and Twitter to, in a way, the kind of most exciting applications at places like Johnson & Johnson, right? Or all the people doing self-driving cars, from GM to Zoox to John Deere with their autonomous tractors. And I think one thing that really excites me, just having been trying to sell ML tools for the last 20 years, is even up until 4 or 5 years ago, when you'd go to a bank, if you had an ML product, they would send you to the innovation team. And I've just learned to hate innovation. I don't know if anyone's at innovation, VP of innovation in the audience. It's drives me crazy, right? Because it's it's not actually trying to deploy something that people use. And I think what I know the Anyscale team is super passionate about is the same as me, where it's we want to make stuff that that people really, really use. Again, I see Dwight here, right? Such a cool application in Whisper, right, where they make a hearing aid powered by machine learning. That's so cool. It really works. It's really in people's ears and helping them hear stuff better. I even would like that for myself, right? When I'm in a crowded room, even at this conference, it's hard for me to hear people. So just the breadth of applications and the breadth of adoption of ML in general is really exciting right now. So that's my pitch. But now I want to kind of talk about this integration that we've built and why you might want to use it. And I would say, for all of you that train models, I just offer, instead of listening to me, if you want to follow along with the code and actually do this, that would nothing would make me more happy than this, right? The Anyscale team has made the setup incredibly easy, right? It's a pip install and then importing a weights and biases callback. You can get toy data with this code or real data, and then you can basically add the logger callback to your already working Ray trainer. And what that's going to do is it's basically going to pull in lots and lots of information by default from what Ray is doing, so that you can actually kind of see the input hyperparameters, see kind of any of the outputs that the model is making as it runs, and then maybe most importantly, go back and rerun your model. So reproducibility is this thing that's people want so badly. And of course, it's reproducing any one particular run that someone did is not hard, right? If you really write down everything that you did and keep detailed notes perfectly, you can reproduce mostly something that happened. But it's when your developer's on the 100th run and they're kind of in a rush, right? That's where you lose the reproducibility. So making this all happen behind the scenes and kind of work forever, I think that's really the key for making real reproducibility, which is necessary, right? If you want to have explainability, you can't have explainability if you can't actually reproduce the model and how it got built, right? If you want to have AI safety, you have to have reproducibility, right? Reproducibility doesn't guarantee safety, it doesn't guarantee explainability, but it's this necessary building block, which is one of the reasons I'm so passionate about making this work, right? And then this is like the fun part. I don't know how many of you have kicked off a distributed training run with Ray Train, but this is like the really cool part, right? Like where you've done something on your laptop, and then it's like, boom, it's on like 32 GPUs. I think this is why our internal developer kind of can't stop modifying this demo that I have for you in a second. But it's just super cool. We also, and I think this was announced yesterday, but in the AnyScale platform, you can now click Open in WMB, and if you've actually used this WMB callback, you'll automatically get this button, and then you can actually just pop open weights and biases. But I guess for those of you who haven't used weights and biases, I want to tell you like why you might want to click on that button, which is available to you, but maybe small, and also you're like busy, right? I mean, the reason that you want to click on it is actually you can see like all the pipelines that you've built, right? And actually, this is all going to be there for you by default. You can log more stuff and add stuff, but you're going to get a lot out of the gate, right? You're going to get a big list of like everything that you ran, and you're going to get a big library of visualizations, which you can, it's built on Vega, and so you can add more visualizations if you want. But we've been doing this for years, and we've been building the visualizations that customers want to be able to figure out, like, okay, what am I doing that's making a model work, and what am I doing that's making a model worse, right? Broadly, right? Is it like, do I have like a training data issue? Do I have a hyperparameter issue? Is there some bug in my code? And you can actually like visualize what the experiment is doing, right? So you can even see things like, am I completely saturating my GPU? Actually, we can like, collect broad aggregate statistics on this. Very few customers are using most of their GPUs, even when the model is training, right? So it's just a simple thing. I mean, anyone can look at how much the GPU is running, but we're just going to track this passively forever, right? So if you suddenly realize, hey, I'm only using 50% of my expensive GPUs, I can go back and look at, what was the code change, what was the commit that caused that to happen, right? And you can go back to any checkpoint in your model and find it. And look at directory application graph course says we're driving 50 to 100 times more ML experiments. That's amazing. That doesn't even seem quite right, but I love that he actually said that. And you get this amazing page here, right? Where and this is really hard to demo, right? But you can see like the Git repo, the Git state, a link back to AnyScale. It's awesome. There's also and we've put a lot of work into saving and analyzing the data, right? So we've built a sense of pipeline and a way to save all the things that happen each step of the pipeline, no matter how big those things get. So we have a system called Artifacts that's kind of designed for the ground up for a machine learning use case, right? So we're expecting tons and tons of files, maybe millions of files, like files to the point where like even calculating the SHA of the files might start to slow down your training if you didn't do it efficiently. That's really what this is designed for, and a system to actually look at the data. It's amazing how many customers we've gone into where the ML team can't easily look at examples of the data that they're using to train on, right? And again, these things aren't hard, but when they're not easy, when you don't make it really easy, people waste a ton of time on like simple problems that's like hard for them to debug. So we just want to make it so like when you log in, if you're doing here the semantic segmentation, if you're doing semantic segmentation, we're going to make it super easy to see examples of what your semantic segmentation is doing at every step on every single model and make it easy to pull that up. And then I think like people underestimate how powerful this is, but we've built a system for saving stuff into reports, and this comes from. I don't know if you've ever tried to replicate a paper, right? A paper has like that little table where they talk about like this, 6 things out of like the million things that they tried and what happened. And it's always like underspecified. And you're like, man, I know you tried like a million other things. Like, why didn't you just put like how well each of those other things worked? We're trying to make it easy, at least internally, to make like a table of all the things that you tried and how well they worked, and actually be able to click in on each one and audit exactly what happened. And then ultimately, I think for the managers in the room, what this becomes is this system of record for all the ML stuff that's going on. And this is really powerful. Like when someone like leaves your company, if you're not like keeping track of all this stuff, when they walk out the door, all the IP that they created walks out the door. Like all the things they learned kind of walks out the door with them. When someone onboards, they're going to end up running tons of experiments that you tried before if it's not in like an organized place where they can find it, right? And so, making it easy to have this like record, like an official record of everything that gets built, it doesn't just help with compliance. It helps actually teams operate faster. And then this only works if it fits into every possible workflow. So we've really, really made a concerted effort at Weights and Biases to like work with all the stuff that our customers are using. I mean, of course, Ray, right? We're here today, but we work out of the box with PyTorch and JAX and TensorFlow and old mainstays like scikit that I love. Maybe I'm the only one that supports that, but it matters to me. And so one more thing, actually, and then I'll show you the demo. But this is really, and people always ask, so how does this work, right? And this integrates into your infrastructure. So there's like a Weights and Biases server, right? That when you're training and when you're deploying, everything is talking to it, right? So it's kind of like application performance monitoring, if you've used that, like you've used a Datadog or something. It's basically like all these things are phoning to a central server. And an example I'm going to show you, and this is probably for the startups in the audience, that central server could be weightsandbiases.com. That's like a simple way to do it. Anyone can do it there. If you want to deploy the server on your own infrastructure into like a managed Weights and Biases cloud, we offer that that too. But everything is going to be like talking to one kind of centralized place, and then people will log in and look there for what's going on. So it makes it easily discoverable for everyone. And this integration is super fast. Takes less than 60 seconds. So really, you can stop listening to me and just try this integration if you haven't done it before. All right. So I'm going to show you a demo. And you can actually follow along if you go to wb.me/anyscale. So this is like a very technical demo, but we've made this all publicly available for y'all. Let's see. So the idea is we want to make something as realistic as possible, but on a data set that's publicly available, so we could open this all up for you. And this really is at wb.me/anyscale. And the idea here, so this is actually a Weights and Biases report. And this is the kind of report that someone really would make at a company, right? So there's sort of a link to a data dashboard, which is probably owned by the data team, the data prep team, if you have that in your company. And then there's a prediction dashboard that's more like the team actually doing the ML training. In this case, we're doing an autonomous vehicle example, so this might be the perception team inside a company. And so the actual use case is provided by it's actually provided by Woven Planet, which used to be Toyota Research. And I think this is actually an awesome data set they just recently released. It's a big data set, which makes it kind of more realistic. And it's kind of a top-down view of various cars and then like LiDAR data for what the car is seeing. And it's labeled with all the agents that might be moving around, like pedestrians and bicyclists and so on, that you might run into. So the challenge here, which actually, it's funny, I should say Woven Planet was a very early customer of Weights and Biases and Anyscale. So it's kind of like fitting that we use this example. But this is something that they really do, something like this inside the company, of course, with even bigger data sets. And they really do it in a similar way to what we're showing here broadly. So actually, all the code used to generate this example is available. So you can see like realistic real-world code. I think our engineer is still modifying this code potentially, but I believe that it runs or ran at one time. But the sort of first part of this code is basically to get the data set into Weights and Biases. And it's actually like what most of this code is doing, because this is realistic code, is actually it's like munging the data, right, getting into a format where it's consumable, right? So that's sort of outside of what Weights and Biases does, but then it uploads it at the end. And then the idea here is like, a data team would make a report like this typically, where first of all, it's just showing, OK, what is this data and where did it come from? Like, what is the lineage of this? And you can see it's kind of nasty, right? It's in these files. They're huge files. They're kind of hard to parse. So 1,000 hours of perception output is not a small thing, right? But then the data team would typically, best practice we see, is they would put it in a format that's consumable by the prediction team, right? So they're basically making a TLDR for this data set, so someone can look at it, once they've prepped it, right? So we have descriptive statistics first of all, right, to get like stats on the data, so there's no ambiguity there, and then also like some insights into what this data is, right? I think like right here, this is probably what you wish you had if you've trained on any data set, right? And so we have some examples here, like, here's the movement of the centroid of the autonomous vehicle. What this kind of shows is that this vehicle, as it's driving around, is turning. You can see this sort of class distribution of the agents. And then I think like most importantly, you can look at exactly like what is this data, right? So you can see here, like this is literally the labeling of the data. You have like a road, and then the green is the kind of vehicle where the LiDAR is, and the blue, these are various agents. Like these blue blocks are probably cars. These might be pedestrians. And we're making it easy to kind of pull this up and even overlay it on top of a satellite view, so you can actually look at, okay, what might these be? I mean, this blue maybe looks like it's a mislabel here, right? So again, I think it's really important, right? But it's actually kind of hard when you look at this data on the woven planet type to even like sort of see like what's going on in this data. So we've tried to make it just like a little bit easier to consume, and then examples of agents and frames and so on. And then what you do with that, right, as a prediction team, is you take that data, and we're showing a couple different steps here. And so, there's typically what we see is there's like a prediction team that's trying to do the training. Their mission is to make a better and better model. Then there's kind of an evaluation step that's outside of that, right, which is like before it goes live into production. And then maybe there's an ops team that's keeping track of the registered models that are actually running live into production. And here, and we think this is best practice, each of these teams is kind of making its own page of what's going on. And again, these are, this isn't exactly how it would look in production. It would be much bigger at each of these steps, but we're trying to make it as realistic as possible. An example where we can also give you full access to it, right? And so on the prediction team, let's click through, and what we're going to see is a whole bunch of model training runs, right? With the goal here is to basically build the best system, right? And so actually, this data is all run on any scale, right? And this is like using, this was actually trained on a laptop originally, right? And then scaled up, kind of effortlessly to real scale. But then the question that you keep having is like, okay, what are like the best hyperparameters to use on this data, right? So, we were exploring it. And if we use RayTune for this, but as you know, hyperparameter tuning is an iterative process, right? Where you try some things and that, leaves some questions, then you want to change some other hyperparameters, and you always end up with this kind of mess, right? And so what the team is doing here is they're basically making some interactive visualizations where, so for example, there's a parallel coordinates plot where I think these are hyperparameters here, and then this is the average loss, right? Which is some notion of how well the model is working. We can select a set of runs here, and this will actually take all the other graphs in this plot, and it'll narrow them down to maybe just the best runs, right? So we can see here the loss curves and the loss and even the GPU utilization of just the best runs in our hyperparameter search, right? So we see immediately like we're using most of the GPU. Oh, this could be better, right? This gets up to like 80%, and for some reason there's kind of like a warm-up period. It looks like across all these models, which is a little bit of a head scratcher. And you can see CPU utilization isn't full, right? So there might be some ways to to improve that, right? And then you can actually go into here and you can look at, okay, of the best runs, what are the hyperparameters that actually really matter, right? So this is a little widget where we actually build a random forest where the inputs are your hyperparameters and the output is something that we picked here, in this case, average loss. And then we look at the importance in that random forest of like what really matters, right? So we can see that the highest importance here is the max number of steps. For whatever reason, there's actually a negative correlation. So it seems like maybe this model needs to get cut off faster, at least in this kind of like range of data. We can actually expand it out to the full range, and it'll recalculate this. Here, actually, when we view all the models in our set, it looks like the learning rate is maybe more important. That's actually positively correlated. But we can write down these insights. And then I think the really important thing is that if I wasn't giving this talk to you and you went in and you were actually trying to figure out, okay, like what's going on, you'd kind of say, well, I'm not sure. Like, I don't know exactly how these things were run. I have more questions. Like I want to go in and look at a little more detail here. And you can actually click on any of these things, and you'll really get all the detail into exactly what happened as this model trained. Right now, this overview, and this is kind of a boring-looking page, but if you're the person that needs to kind of figure out like what happened to make a model work better, you're so happy, right? You can basically clone the repo right here and then get to exactly the state when this model ran, right? Because we're saving the git SHA, and actually because people don't always check in their code before they run a training run, we'll even keep a diff patch against your latest check-in, so that you can really get to exactly where the model was when it ran. So anyway, this is where the perception team would be living, right? But then there's stuff beyond that, right? There's basically evaluation that you want to do. And so what we see with autonomous vehicles typically is that folks need to basically test the model on outside data set, or in the real world, maybe multiple data sets, right? So we held out some of this data to see how well it would do, to sort of simulate the kind of stuff that you might do before you let something go live into a car, right? So we have evaluation runs here where we take candidate models and then compare them. And as you know, you want to compare things not just on aggregate statistics, but you want to actually look at examples of like, why is this model on this particular one doing something different than a different model? So there's like a debugging functionality here. You can also, like, if there's like one case that the CEO gets really mad about, you can make sure that that gets like pulled up here, and like we're not going to like mess up the pet project of the CEO of the company. It's a real thing that we really do see. I try not to do that myself, but and you can see there's actually animated examples that we can pull up. It's kind of fun. You can actually watch the car drive around. And see how well the predictions work here. So you can see these cars in the intersections as they fly around. And then finally, we have a notion of model registry. So you can keep track of what goes into production and what the lineage was of that thing that went into production, right? So we have a dashboard here where you can go in and you can pull up, I think I did it over here, essentially like the lineage of all the different runs and what data they were trained on, the metadata of any run. These runs can get marked when they went live into production and when they were taken down. And again, all that is collected passively so that even if someone kind of forgets to mark something after the fact, you can look at exactly when a thing went live in a car and when it was taken out of a live run in production. And I mean, it pains me how many fun features I skipped over. So again, I would just say, go to wmb.me/Anyscale, and you can find all this code here. This all uses Anyscale for the scalability and the infrastructure. And all these notebooks will actually run and report live to a weights and biases dashboard that you can look at. And so, just a couple more links. If you want to get started with weights and biases, go to docs.wmb.com. If you want to get started with Ray Air in WMB, we made a getting started page for you at wmb.me/rayair. And then we'd also love it if you came by our table. Today we haven't met all of you. We have a whole bunch of engineers that are excited to talk to you. We actually give away socks, which is kind of the worst swag because no one can see it. But we are the only company with socks here today, which I think if you're traveling, socks, pretty good thing to have. I like our socks, so you can come get those. And the sales team says that if you scan your badge, they're going to give away a free license to someone. So you should definitely come by our table and say hi. But thank you so much. Any questions? Yeah. Yeah.
So there are quite a lot of tools out there nowadays. Like you posted maybe second or third slide showed that there's too many tools.
Yeah.
So so just for example, there's Hydra, there is waste and bias, and there is GitHub Actions, and you can put all of these in a pipeline.
Yep.
So one by one, you can run the whole end-to-end ML. Life cycle, right?
Yep.
So for weights and biases, in addition to, like, I kind of call weights and biases as a ledger of your ML, right? It keeps track of all the. So what's the next, items in your pipeline of product, right? What's next for your product pipeline?
Yes, that's a great question. I think the biggest ongoing project for us is to work really well with all the tools out there that people actually use, right? So, Hydra integration is super important. Making that work well, is really important to us. GitHub Actions, actually, you're mentioning another integration that's really important to us, right? There's also, kind of the big cloud like SageMaker integration is really important. Like all these integrations are really, really critical. And then, of course, the Ray integration and Anyscale is super important. So kind of making this work all seamlessly is one huge chunk of undertaking. And then there's also like letting people make their own visualizations and operations on our platform that gets more and more important as people do new applications that we hadn't thought of. And then finally, there's kind of new blocks of functionality. So for example, the model registry that I showed you is a new piece of functionality that came out this year. We have some plans to do kind of more around helping people in production with their models, because that's the main thing that customers are asking us for these days. But those are kind of the big themes of of work underway. But I really pride ourselves that as a company, we spend a lot of time listening to users and customers. And so you totally get a voice if you want to, if you want to come and join our Discord and like talk to us about what you want to see. We love to actually have conversations with motivated people about that. Thank you. Yeah, thank you.
Hi. You mentioned earlier that you do some kind of instrumentation so you can see the performance, like or your GPU's usage and performance and stuff like that.
Yeah.
Does that come for free by adding the weights and biases callback, or are you running something on the hosts, and then like, is that specifically for like some kind of hosted cluster, or if I have my own cluster, do I have to do something to it to get that performance benchmark?
That's a great question. So I guess I slightly so the weights and biases callback, you also need to call wb.init. And so what that's going to do is is that you're looking at me like I'm wrong? Am I wrong? Does it automatically call init? There's been a debate internally about whether or not to do that. Okay, I'm right. Good. So when weights and biases starts, it creates a process that runs locally that your process is now talking to. And that process is doing things like automatically looking at your system metrics and doing the best it can to look at like what's the underlying hardware that you're on and what's going on. And then it's streaming that to a central server. So we're trying to give you as much information as possible out of the box, because tracking all this stuff is actually really cheap, and you don't know until later often what you really cared about, right? Like GPU usage, most of the time you don't care, but when you do care, you're really happy that you had it on every run that you did ever for debugging. Does that answer your question? Yeah. Or,
Sorry, that's all the time we have for questions.
Sorry.
Please give a round of applause.
We would love it if you came by our table, yeah.
Has a table for any questions afterwards.